This doesn't make sense to me, but okay, whatever. Okay. All right, anyhow, okay guys, let's go back to this problem. Okay, so position. What do we know about position? Okay, so regarding position, I'm gonna do this. So for position, what do we care about? We want to know where it was at time equals 0. We want to know where it was at time equals 2 and where it was at time equals 4, right? Oh, you're right. Okay. Well, we don't really need 3.
Why not?
Because we want to know where it started, right? So S of 0 is going to be 0 cubed minus 0 plus 0 plus 4. So it starts at 4. S of 2 is going to be 2 cubed minus 9 times 2 squared plus 24 times 2 plus 4. What'd you get?
I got negative 20.
Whoa. Okay, 8 minus 36 plus 48 plus 4. So that is... It should be 24.
Yeah. Woo! But I still got that.
Okay. So let's do S of 4 at time 4. What did you get? 4 cubed minus 9 times 16 plus 24 times 4 plus 4. 20? Okay. Okay. I guess you might want to know S of 3. What'd you get for S of 3? 22? Okay, now this one doesn't have to be on the same scale.
You don't need S of 3, right?
I don't think you do. Let's see. So this thing never went. Okay, so this is position. Okay, so this is a.
And you wanted us to do this all within a shortened schedule.
Oh yeah. Okay, so all right. So where did it start?
4.
Started at 4. So let's make this be 30. Okay. Okay. All right. So we start at 4. Okay. So at t equals 0, we start at 4, and then where do we go?
So you went to 24.
Right to 24. And then go back left to...
It went right all the way to 2 seconds. At 2 seconds, we reached 24.
But it was, the acceleration was negative as it was slowing down.
Okay. So by t equals 2, it went that way. So it went to the right. Yeah. And then between 2 and 4, it went to the left. Between 2 and 4, it went all the way to 24.
Between 2 and 4.
I mean 2 and 4 seconds. And then it went to 20. So it went down this way, right? 20. Okay, so this is at t equals 4. And then after t equals 4, it went back to the right. Oh, that's complicated. So then it went...
Because at 4, the velocity is 0 again. At t equals 4.
Yeah, and it went to the right. So after that, it went that way forever, right?
Yeah.
Wait, so then... Wait.
So basically, it went... Doo, doo, doo.
Ooh, what is that?
Doo, doo,
So
doo.
second 3 is 22, right?
At second 3, it was at 22, yeah.
And then it went to 20
Mm-hmm.
at second 4.
So it went... Whoop, doo, doo. Right, left, right. The sound effects don't mean anything. So right, left, right, right? So basically these two are the most, are the conclusion. Like position-wise, it went this way, and this way. How do we know that? With the velocity and the position. The motion-wise, by combining these, we know that it was slowing down and then speeding up and slowing down. and then speeding up.
So the velocity tells us what direction it went.
Yeah.
Okay.
All right. So this is the diagram, but words-wise, how should we say this in words? Okay. The particle moved to the right, right? From t equals 0 to t equals 2. To the left. If it was the AP test, I wouldn't, but on my test, I get you. To the left from t equals 2 to t equals 4. And moves to the right after t equals 4. Or you could say, yeah. When t or
When t is greater than 5.
we can also say it slows down from t equals 0 to t equals 3 and speeds up after t equals 3. Okay, so that's what you're putting it in words. Okay? How should we grade this?
5 points. Yeah, 5 points.
4 and 5
For velocity, acceleration, motion, position, and then the written description.
Yeah.
Yay.
Okay, so, but everything's got to be right, you guys. So, this is what I mean. Okay, 1 point for this graph. Okay, so you don't have to, this can start, the time can start at 0, so you don't have to have an arrow because we don't have negative time. So, you have to have this from 0 to 2 to 4 plus minus plus for velocity, 1 point. Acceleration from 0 to 3, you don't technically need this 2 here. Okay, so 0 to 3 to infinity, negative, and then positive. That's another point. The motion is saying slow down or have the minus, plus, minus, plus, or slow down, speed up, speed up. Okay? Another point, this is tricky because you have to know that it starts at 4, goes to 24, goes back to 20, and then goes towards the right to infinity.
So you needed to write 20 and stuff?
Yeah, you had to know, wait, what do you mean?
I just wrote 2, 3, and 4.
For here?
Yeah, for position.
2, 3, and 4. You have to know that the particle starts at 4, and it goes all the way to 24,
Okay.
and then goes back to position 20, and then goes towards the right forever.
What about like after t equals 4, you then write it onto the
You have to, because the time gonna stop. You need to know the beginning. Okay? Everything I just said. And then 1 point if you think that you had a good description. Let's take off a point for that. Yes? Oh. Yeah, so take off 1 point for that. And then if you did everything right according to your error, that's fine. But yeah. Okay? Yeah. Okay. All right. All right. Wonderful. Questions? Okay, but you guys kind of get the hang of it, right? Yes. What's the most difficult part? The finding the what?
The written was the position, and then like after t equals 4, I just left it there. I didn't write it.
Okay, but the particle didn't stop, right? Because the velocity was positive after t equals 4, so it keeps going. Okay, we learn by doing, and we learn by our mistakes. Okay, this one is a rock thrown vertically upward from the surface of the moon at a velocity of 24, so that's an initial velocity, right? And reaches a height, so that's the position function. So find the rock's velocity and acceleration as functions of time. So the velocity is going to be 24 minus 1.6t, right? And the acceleration is going to be negative 1.6. Is that right?
You don't have to put like meters per second.
You really should.
You should get extra points.
Because on the unit test, I will take off points if you don't have units.
Or can we just pass?
That's fine. Okay?
It's not a point, what is it? What if I forgot the square?
No.
And you got it wrong.
Wait, so if we didn't put the units, it's wrong?
No, for right now, I will let it be, but add it in your with your pen because you need to. Yeah, it should be wrong.
So this is 1 point or 2 points?
Take a point
Oh, let's talk about that at the end. Okay? Just put a check. If you have it right, put a check mark. Yeah.
Oh,
4 for 6
I squared 28.
That's probably the highest I've
So what's it out of?
Let's talk about that at the end. How long, just put a check mark if you got it right. How long did it take for the rock to reach its highest point?
Alright, so that means velocity is 0.
Yes, at the highest point, because the rock is thrown upward, right? If the rock is thrown upward, then it's the velocity, initial velocity was 24, and then it's going to go down to 0, and then the velocity is going to turn negative. So we want to know the rock reaching its highest point means that the velocity is 0. So we let the v of t, which is 24 minus 1.6t, equals 0. So 24 equals 1.6t. And so t equals
Negative.
24 over
Oh,
24 over 1.6, which is 240 over 16, which is, well, if you divide by 4, then it's 60 over 4, which is 15, right? So it's going to be 15 seconds. After 15 seconds, it took 15 seconds to for the rock to reach its highest point. How far did the rock go? How high did the rock go? Well, the highest point is 15 seconds. So how high is where it is after 15 seconds, right? So it's 24 times 15 minus 0.8 times 15 squared. You got 180? So 180 meters is how high it went. When did the rock reach its half of its maximum height?
yeah, okay.
What was its maximum height?
180. 180.
The maximum height was 180, right? So what is half of its maximum height?
So then you
90.
set position equal to 90.
Miss, can you use the quadratic formula?
Okay, let's try that. So we want to know when 24t minus 0.8t squared equals 90. So we can say that's when 0.8t squared minus 24t plus 90 equals 0. You can use your calculator, you can use the quadratic formula, you can multiply the whole thing by 10. So it's 8t squared minus 240 plus 900. No, because I moved it to the other side. Yeah. And let's use the quadratic formula. T equals x equals negative b plus or minus s squared. Wait, why don't we reduce that first before we go all crazy with the big numbers? Well, that gets rid of the decimal. That's nice.
Okay, so we want to
So divided by 4, so 2t squared minus 60 plus 900 divided by 4 is 450 divided by half, which is 225. Is that right?
you need to use the formula, the quadratic formula? Wait, why can't we just like, no, it's 90 because it's not?
No, that's not the answer.
We're trying to find out what t. We're trying to solve for t.
So we got a 4, right?
What
Yeah.
about
If you said when it reached 90 meters, that could be
What?
It could be like, it reached its maximum height when it reached 90 meters.
But when is that?
When it reached, that's an answer, miss. Technically.
Okay. Yeah, technically. Okay, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I guess I could factor that too, but x equals negative b plus or minus the square root of 225 times 8. 16.
This be the answer.
Let's see. Okay, 60 plus or minus 1800 over 4, and the square root of that is 60 plus or minus 10, we're at 18 over 4, which is, oh, and what, 3 can come out of that, 60 plus or minus, wait, what comes out of that, 3, 30 over, we're at 2 over 4, which is 15 plus or minus, what's 30 divided by 4? 7.5, we're at 2. Okay, so can somebody put in their calculator? You didn't have to do all that. You could have just put this in your calculator from the first step. I just think it's fun.
What if you didn't simplify?
You're like, I thought you were saying, what if you didn't think it's fun?
What is that 25? So, oh, 7.5.
Yeah.
So you can divide the 30 by the 4?
Do it twice. Do 15 plus 7.5 divided by 2, and 15 minus 7.5 divided by 2. Times red 2.
You can do 30 divided by 4?
Yeah.
Okay.
And let's see if it's what Mario has a quadratic formula in his calculator. You could also do this. There's many ways you could do this. You guys graph it and find the zeros on the graph. That's probably the easier way. That's what I would do if it were on a test. You're right there, always watching movies.
What class is that?
World history.
Yeah, can we watch movies and then learn how to use it at the same time?
Sure. After the AP test, I'll show you stand and deliver.
So,
Part of the class, like 50%.
Fill the hole. Okay. Math is in your blood.
so 15 plus 7.5
Yeah.
is 25.
25 point what?
0.6.
And then?
And then 15 minus 7.5 square root is 4.39. Miss, what if we didn't simplify? 'Cause I didn't have time.
That's fine. You could still get
So now how do you know what time it is?
right here.
But it gives you 2 times.
Yeah, because it went up and it reached 90, and then went down and it reached 90. Because like the particle, it went up.
Oh,
So it went all the way up to 180, but it went up to 90 twice, right?
yeah.
So there should be 2 answers.
Wait, can
Yeah.
we see this?
So, you know what, let me show you guys probably a much easier way instead of doing a quadratic formula. I just did it because somebody suggested it and it seems kind of mathematically
Is that
for the
39?
moment.
What
But-
is that scribble?
Huh?
On front of the 39? The little scribble in front of the 39? Oh, 4.
4.39.
So
Okay.
those are both the answers?
Yeah.
Oh, so you have to go on the way up and on the way down.
On the way up and on the way down. What you could have done is you could have put in. Okay. All right. So what you could have done is put in, what did we have? 0.8x squared minus 24x plus 90, right? Zoom 4. You were going to see a parabola. We want to know when that equals 0, right? So let's zoom out. That should be a parabola facing up. Zoom out again. No, because that's not going to be accurate. So there's two places where this parabola touches 0. Can you guys watch? This is important. Instead of using the quadratic formula, you could figure out when does this. Let's change the window. So we want to know going from, we could go from 0 to like 80. And then here we don't really care, so we could just go from -5 to 5. Oh my gosh, that's loud. Okay, so we want to know the two places where the parabola touches the. I want to change that. So we could just go to 40. So two places where the parabola touches the x-axis, and I'm going to go to second calc, okay? And I'm going to press 0. And I want to know the left bound of that 0. Where am I? Do you guys see the little spider? You're right. Okay, there. The right boundary is. I'm just gonna put it here, and then I'm just gonna guess that it's somewhere here, and it tells me, oh, 4.39. Do you see that? 4.39.
Now go to the other side.
Okay, now let's find the other side. So press 0 again, and I'm gonna go down. What? That's what we're doing.
No, I mean, but like, isn't there like a thing where you can just say 5 roots?
Is there?
Yeah.
Okay, so let's go here. Left bound, right bound,
Oh, yeah. Can't you just like plug in?
and there, 25.6.
Why can't you just go to the table and then look at the bill?
Oh, true, true. You could also go to the table. So you want to know when it equals 0, right? So if I put in, I have to go to
Press
set
alignment, it'll tell you.
table set. So I want my dependent variable to be ask, okay? And my independent to be auto. So I tell them, hey, look, I want this to be 0. Can I clear that?
If you go to the graph while it's on trace, you just
Wait,
have
hold
the
on.
0. Yeah, it'll show you.
So I want this to be 0. Oh, that doesn't work. Maybe that doesn't work because it wouldn't pass the vertical line test.
Or you can go to
Where? This?
To trace.
No, but trace is not accurate.
No, back on the graph. While you press trace, you press 0. Press trace.
Not press 0.
That's for x.
No, we're trying to find. Oh no.
No, we want to know the y value. So you have to press second trace and you have to do 0. Okay? Or you can use a quadratic formula. Knock yourself out. So basically there's 2 types. So on a word problem, you guys, especially on an FRQ, I wouldn't just leave it like that. You would always have to have an answer. Therefore, when t equals 25.6 seconds and t equals 4.39 seconds, the rock will reach half its maximum height. Okay, make sure you always end a word problem with a sentence. I'm not going to expect you guys to do that on this quiz because I just told you right now, but do always end a word problem with a sentence or a phrase. That's a good question. I guess the other ones were a little simpler, but if it was an FRQ, I would overdo it, you know? Okay, how long was the rock aloft? What does that mean? Aloft? In the air. How long was the rock in the air? In this, right here, the picture is useful. It's in the air this whole time. Well, we know that when it reached its maximum height, it was t equals 15. So if gravity works the same way on the moon as it does on Earth, you're right, it would be 30, right? Because it took 15 seconds to go up, it should take 15 seconds to go down. So, but if you weren't sure, what could you do?
Wouldn't it accelerate the
Oh, does it?
Yeah,
Yeah, it's 'cause of gravity.
No, that's not what Mr. Bertucci said.
I don't think so. I think it's.
Well, you are in calculus, not physics.
Wait, hold on, wait.
Okay, let's check. Let's check. Double check. How can we double check using math?
Okay, how long was it?
Aloft.
That means in the air, right?
In the air.
So that means you have, because it takes longer to go up.
It takes longer to go up.
Oh wait, you
Does
find the
it?
zero.
Does
You
it?
find the zero.
True.
Find when s equals 0.
You find when
And then
s
you find,
equals
you find the
zero.
position. You find the
Okay,
time.
because when s equals 0,
Means
It's
it's
gonna
when
give you two. It's gonna give you two.
yeah,
the particle
has is at the starting point and at the end.
just started or is reaching the ground, right?
Yeah,
So you let S
Or hit the ground.
yeah.
So let s of t, which equals 24t minus 0.8t squared equals 0. So that means if I factor out the t, so 24 minus 0.8t equals 0. So then t equals 0 or t equals,
Miss Han, what did you just do? Why did you make this 24?
I factor out the t.
Oh. $30.
30.
Wait, what? Wait. Oh, because you yeah.
So therefore it takes, oh no, the rock is aloft. You guys know about the 3 circles, right? This is not La Vida Loca. This is therefore the rock is aloft for 30 seconds.
So then there's no gravity on it.
There is gravity. The gravity has an effect of negative 1.6. But I guess the gravity is acting on it as it's going up, and it's acting on it as it's going down,
Well,
so it's really
gravity is-
equal.
Yeah, it's going. Yeah, because it's going against it as it goes up, and then it's
Yeah.
going, but
For it as it goes.
damn. But then
Yeah,
that
you need to
would-
talk to Mr. Vertusio about that and come back with an answer for me tomorrow.
Wait, I have an impression.
Why does it go to take just as long to go up as it goes down? Because it has an initial velocity, that's why.
So if it didn't have an initial velocity, the acceleration would just be 9. Because
No, not on the moon. On the moon it's negative 1.6.
so how come the 1.6 doesn't play a role here?
It did. So that's because it went up with an initial velocity of 24, but did it go up at a speed of 24 the whole time? No, because the gravity pushed it. So then, woo, and then it slowed down. On the way down, it didn't have that benefit of that initial velocity. So that's why maybe even though it's gravity's pushing on it, it evens out.
I don't know, because like, I was watching something. It says when you shoot a gun into the air, like, it comes back way faster than like when you shoot it.
Ah, it comes back faster than it when you shoot it up.
Yeah, like when you
Maybe
shoot
that's the aerodynamics of the bullet. I don't know. You should ask Mr. Bertusio about that. Okay, find the equation of the tangent line. Okay, you guys should all be experts at this. But oh wait, how many points? Let's do. Well, these ones are all kind of similar. So, 1, 2, 3, 4.
it should be worth 2.
This one, yeah. Let's do 2 points, 1 for each second.
A should be 2.
5, 6, 7.
Wait, why is D 2 points?
Yeah, why is D 2 points?
Saying A should be 2 points.
No. Oh,
A should be acceleration.
that's so easy. No, A should be worth. Yeah, everything's worth 1. A, B, C, D, and E. 5 points. 5 points.
Miss,
Okay.
what if I left it like this? You're saying, yeah, it should be 2. Because I didn't know what you
Does
said.
it simplify to the same thing?
Yeah.
Yeah, that's fine. Okay?
Question 3.
No, I will not mark you if you didn't put meters per second. It's fine. Oh, you gotta be careful.
So each question.
I don't know. You use your judgment. I will trust you. Okay? What you think is appropriate. Okay, woo! We took the whole class going over this quiz. Okay. Alright, so find the equation of the tangent line. Find the equation of the tangent line. To find any equation, we need a point and we need a slope. So the point is going to be pi comma y of pi. And the slope is going to be y prime of pi. ¿Que no? Get Z. That's right. You guys get me? To find the equation, we need a point and a slope. The point is the x value is pi. The y value is what the output is when you input pi. The derivative, the equation, the slope is going to be the derivative of pi. Derivative of y at pi, right? Alright, so let's see. Yeah. So the derivative of sine is? Cosine. The derivative of cosine is? Negative sine. So y prime at pi is cosine of pi minus 2 sine of pi. So it's going to be cosine of pi is negative 1. Sine of pi is 0. So it's going to be negative 1. So the slope is negative 1. What is y of pi? Y of pi is sine of pi plus 2 cosine pi. Sine of pi is 0. Cosine pi is negative 1. So it's going to be 0 pi comma. Do you guys know that this is the same question I put on the last quiz?
Yeah.
Okay. Oh my gosh, Robert. So y mod plus 2 equals, I should put it on the test too. Just for Robert. Just x minus pi.
Should be 3 points.
Yeah, 3 points.
Really? Is this up to
Yeah.
Wait.
For what? 1 point for the slope being negative 1, 1 point for the point being pi comma negative 2, and 1 point for putting it in the slope form.
You know what? I think I got
That's fine. You asked me the last time.
Oh.
That's fine.
Wait, hold up.
Hold up.
2 points. What was the first one?
+1.
No, you gotta understand the question.
I got page. So I got 4.
Okay, guys. We have 10 minutes. 7 minutes.
So we should get started on our post-weekend homework.
No, we'll do some practice. Okay, we'll play bingo.
What's the whole thing out of, Brittany?
Oh, good. Can I have a test quiz back? You don't need to do it? No.
I got pretty good, man.
You did better than me. How did you do better than me?
Me?
Yeah.
It came like that, or you really?
Sometimes I have a copy.
Did everybody get a practice, a bingo? Here you go.
Oh, we're gonna go playing games?
Kind of, yeah. We are playing a game. Huh? Yeah. Can you get one back? Yeah. The old one, you can keep that.
So what do we get like?
Maybe I'll give you candy or something.
We get that candy.
Thank you. Yeah, you did. Okay. Okay. So, don't lose this. I want to talk about it tomorrow, but the back. Okay, the bingo side. You do in whatever order you want. You have to try to do as many derivatives from 1 through 15, and when you get the answer, you circle that box. And the first one to get bingo is the winner. Okay?